For question 1.1, we are given the following graph and we want the DFS pre-order, DFS post-order, and BFS order of the graph traversal starting from vertex A. We are also breaking ties alphabetically. To start, let's go over the post and pre-order steps. While traversing the graph, we want to maintain a stack of nodes and a marked set. As soon as we add something to our stack, we note it for the pre-order traversal. The top node in our stack always represents the node we are currently on, and the marked set will hold nodes that we have already visited. After adding a node to the stack, we visit its lexicographically next unmarked child. If there is none, we pop the topmost node from the stack and note it as part of the post-order traversal. So going back to our graph, our starting vertex will be A. A has two unmarked children, but we're going in alphabetical order, so we're going to add B to our stack, pre-order, and marked set. The next node we're looking at is B. B has an unmarked child, C, so we're going to add it to our stack, pre-order, and marked set. C has an unmarked child, F, so we also add it to our stack, pre-order, and marked set. Okay, now we're at F, and we see that it has no unmarked children, so we're going to pop it from the stack and note it down for post order. Okay, C has no unmarked children, so we add it to post order. B has no unmarked children either, so we add it to post order. And we're back at A, but A has an unmarked child, D, so we're going to add it to our stack, pre-order, and marked set. D has an unmarked child, E, so we're going to add it to pre-order. E has no unmarked children, so we're going to add it to post order. D has no unmarked children, so it's added to post order. And now we're back at A again, but all of its children are marked, so we add it to post order. And now we are left with an empty stack, so we are done traversing. Next, we want to take a look at the BFS traversal, also known as level order. We once again start at vertex A, add it to our traversal, as well as the marked set. Next, we add B and D to BFS and mark them. Then we consider all vertices that are connected, which includes C, F, and E. And next we add C, E, and F to BFS and mark them. So once again, we consider all unmarked nodes one edge away from these vertices. And since there are none, we just add G and we are done.